Welcome to Linked Data Engineering. This is lecture number 3, Linked Data Vocabularies and Ontologies. We are now come to the last section of the lecture, and this section will deal with how you create your own ontology and how you follow specific methodologies in doing so. Okay, how does this work? Of course, in the ontology development process, we start with something and then we go some strange ways, and in the end we want to come up with a great ontology. And this picture, it's quite interesting, simply because there is no one, let's say, unique way in which you really reach or arrive at a great ontology. There are several ways you can go there. And the point, of course, usually the design of the ontology somehow is guided or is targeted or determined by the application you have in mind for your ontology. So for what purpose should it be used? Therefore, often very different ways to go a specific way, to follow a specific way can be chosen from. Okay, we will start with an example, or you will learn this by doing an example. And the example we want to follow here is given in the Ontology Development 101. This is almost 16 years old, from 2000, and it has been issued by Natasha Noy and Deborah McGuinness. And the ontology that is designed here is concerning food and wine. So it's about wine. So these people, of course, that have designed the ontology, they live somewhere in California. Therefore, Californian wine growing regions are involved there. And of course, they also reflect to French wine growing regions. And then also a lot of knowledge which comes from books like this one, Wine for Dummies, is put into this ontology to answer questions like, for example, which wine fits to fish or to seafood and stuff like that. So we want to develop a shared ontology on wine and food. The Ontology 101 process is an iterative process. So you see here several steps which we follow. They are consecutive, but this repeats continuously, which means in each step of the process you can evaluate, and if you are not content, you can go back and refine. So the process is a continuously repeating and improving process, which in the end tries to develop an improved ontology. And as we have already said, there are always different approaches for modeling ontologies. And in the end, of course, the desired application of the user somehow determines which way we go. Keep in mind, there is no one correct way to model a domain. There are always viable alternatives to go. Where do we start? First of all, we have to think about what is the domain of my ontology. What kind of knowledge do I want to be covered by the ontology? And then I should also think, for whom is the ontology intended for? So what should the ontology be used for and by whom it should be used for? What types of questions should be answered with the knowledge represented in the ontology? And who will use and maintain, of course, this? And to do that, usually you start by putting together something which is called competence questions. What are competence questions? Competence questions are, in general, questions that should be able to answer with the help of the ontology that you are going to develop. For our wine and food ontology, the questions could look like that. For example, which properties of the wine should be considered for modeling? And is Bordeaux a white wine or a red wine? Should something like this? So how should this, is this some fact that I wanted to have represented with my ontology? Does a Sauvignon Blanc match with fish? Which wine matches best for grilled vegetables? And so on and so on. So you can come up with lots of questions. These questions, of course, are determined by the application you have in mind. And of course, you do not pose questions which would be out of the focus of your application. So you see, according to the questions that should be answered in the end, they, of course, are determined by the application you have in mind. In the end, also, the ontology you are going to develop will be determined. So, next thing, we have learned that, of course, this is a repetitive cycle somehow. Of course, during the life cycle of the ontology, the competence questions might change. The world is changing, and also sometimes the focus of the application is changing. So therefore, this might be subject of change. Next thing, before you start to developing something new, you should definitely consider reuse existing ontologies. Ontologies are things that should be reused over and over again. We have heard that we have an open world. We live by an open world assumption in the semantic web and the linked data community and environment. Therefore, open world means there are underspecified things out there which can be reused by others and refined by others according to their specific preferences. And why should we consider reuse? Simply, it saves you money, so it saves costs. And on the other hand, you might be able to apply tools that are applied for other existing ontologies and also now for your own ontology. And in order to reuse ontologies, of course, that have been validated by their application, so you can be sure that they are really working in some sense. Therefore, you should consider to reuse existing ontologies. And of course, only if you don't find a suitable ontology or if the adaptation of an already existing ontology is too complex, then you should create a new ontology. Now let's create a new one. But before you start with defining classes and properties, first of all, you have to develop something which is called a terminology. So simply think about concepts. What are you talking about? What are the main concepts? And which properties should these concepts have? What do we want to say about these concepts? So this is simply a collection of vocabulary terms that are somehow important for your ontology. So for example, what should be represented should be wine, grapes, wineries, locations, a wine's color, a wine's body, flavor, sugar content, subtypes of wine like white wine, red wine, or Bordeaux wine, or Californian wine, and stuff like that. And also the types of food, seafood, fish, meat, vegetables, cheese, everything you like to have represented. You should put here in your terminology, which is a large vocabulary which contains the most important terms that should be covered with your ontology. Next, we come to the classes. Now, really, the definition process starts. So we want to define the classes of our designated domain. So for example, the class of wines, the class of wineries, the class of red wines. The only question is here, how do we decide which now is a class that we want to define? Usually in a class, things or objects are collected which share some similar properties. So keeping this in mind, it depends, of course, how you aggregate, on which property you really look. This determines what kind of class you are creating. And to model classes, and especially then class relationships, how are they related in terms of subclasses and superclasses with each other? There are several ways to start. Most easiest one, you can start top down. So you start with the most general concept that should somehow be represented in your ontology, and that might be a beverage for your wine ontology. Then you say, okay, beverage, there are alcoholic beverages, there are non-alcoholic beverages, and then let's go deeper in that hierarchy. The non-alcoholic beverages are not so interesting for us because we have a wine ontology, so therefore then in wine we determine that from the alcoholic beverages we might have, for example, wine, beer, liquor, or something else. But wine, of course, is here the most important subject. Therefore, we will then split also wine into subclasses like white wine, rosé wine, red wine, and stuff like that. So this could be a typical class hierarchy that has been created in a top-down method. And with this, you look at for example, you look at the color of the wine as the main decision property to model that. On the other hand, you could also do this in a bottom-up approach. So you would first think of what are the single, or let's say the most specific classes that I want to have in my ontology. That could be, for example, Bordeaux white wine, Bordeaux red wine, Chardonnay white wine, Merlot red wine, and so on and so on. So you have here the region and the color, for example, as distinctive properties that determine the classes. Then if you start at the bottom, you have to go to the top, so it means you have to somehow subsume these under superclasses. You can, of course, here put together the white wines, and on the other hand, the red wines, and of course, all of them are wines, and wines are beverages. They are even alcoholic beverages. So this would be a kind of hierarchy which is created in a bottom-up method. And you see here, according to with which classes we start, we end up in something which is quite different from the top-down approach. So which one should you choose? It depends on your application and it depends on the properties you have in mind. This is a question you cannot answer in advance. There is even a third method which says we start with absolutely the most important classes, no matter on which layer in that hierarchy they are. So for example, I could say, yep, according to my personal preferences, the most important classes in my ontology should be red wine, white wine, and of course, yes, Bordeaux wine, definitely. So, next, of course, you could subsume or you could put everything together under the notion wine. So wine would be a class, then would be the superclass of all these classes. And of course, then you could say red wine, we have Merlot red wine and we have Bordeaux red wine. And on the other hand, white wine, we have Bordeaux white wine and we have Chardonnay white wine. And then we have another class, Bordeaux wine, and as you might see here, we can of course put those two, Bordeaux red and Bordeaux white, under Bordeaux wine. So this is not anymore a strict hierarchy. And these class hierarchies, they do not have to be strict, they can overlap. This is not a problem. And you see it again, a complete different hierarchy, a complete different class system, nevertheless representing wine. And it depends on what you think is really important, which classes are really important, and how your hierarchy should be structured. So these are decisions that are guided by the application you have in mind and how this application should work. I forgot the alcoholic beverage. Okay, next point. We have the classes. Now let's define the properties. So how are the classes related with each other? So I do the property definitions. First, I look, for example, what kind of attributes should these classes have? So what's the color of the wine? So every wine should have a color, every wine should have an amount of residual sugar, every wine should have a producer, and so on and so on. So what I do now is I simply state what are the relations between my classes and what kind of properties should each class have with which property with which properties the class should be characterized. And in the next part, you put constraints on your property. So of course, you have to specify, for example, what's the domain, what's the range on your property. And of course, you also could, for example, say here, this is a transitive property, this is a functional property, this is an asymmetric property, and so on and so on. So you put constraints on them. So for example, for the wine ontology, you could say the name of the wine is a string, and the producer is an instance of winemaker. And then if you have classes, if you have properties, including all the constraints you want to define, then you could create the instances. And of course, all the instances you create, they should be member of the classes, which means the instance then has as type exactly the class and also becomes the type of the superclass of these classes. So then you define instances and also relations among instances. So an individual can be related to another individual via a specific property. This then would be the last thing you do then here in your ontology. And then in the end, you could represent knowledge like, for example, the glass red wine that I drank last supper. This is a very quick, of course, process and only a very quick explanation how to do this. If you are interested in a more detailed description of this process, please refer here to the document I have linked in the slides. And keep in mind it's an iterative and repetitive process, which means after each step, of course, you evaluate what you have done, you think about if everything is correct, and probably you go back one step to do a refinement. And the other thing is, of course, this ontology might not stand forever in the same way, simply because the world is changing and also your applications that use the ontologies are changing. And then, of course, it's subject of adaptation and improvement. So this ends our lecture on ontologies and knowledge representations. We have learned a lot about the OWL web ontology language and also how to create ontologies, how to use ontologies on the web. And of course, I invite you to try out everything we have done here in this lecture at home and to deepen your knowledge and to explore what is out there, especially in DBpedia, because we will also refer to DBpedia in the next part of the lecture. So in the next lecture, lecture number 4, we will query RDF data with a special query language which is called Sparkle.